Hello everyone. Let us now discuss LeetCode 1765, map of highest peak. We are given with a m by n grid where a cell will be containing either 0 or 1, and 0 represents water and 0 represents land, 1 represents water. So here we are given with we need to make all the water cells as 0. That is the first thing which we need to do. Make all water cells as 0. And the absolute difference between the adjacent elements. What do we mean by adjacent elements? The up one, the right one, the down, and also the left should be maximum of 1. That means at most 1. So the absolute difference should be maximum of 1. And it doesn't mean that if you have a 0 here and you can make it negative -1, or you have 1 here and you can't make it -2, because the cells should be non-negative, and then we need to make it the maximum height should be maximized. That means, let me write it here, maximize the maximum height. So that's all for this question. We need to consider these rules and make the maximum height maximize. Let me take the height matrix which is having the same size, and I'll make all water cells as 0. I have the water cell at 1 here and I'll make it as 0. Now I have another water cell at here and I'll make it 0 here. So our matrix, the height matrix, will transform like here a 0 here and here a 0. Now the thing is, the absolute difference should be 1. So the adjacent elements, the adjacent cells, what are adjacent to this one, this one, and this one, and these three are not visited. If you see, they are even only -1 till now, so they are unvisited. Let me make it the absolute difference as 1. So if I can make 1, I can get the maximum height maximized. Here I have 0, here I have 0, here also I have 0. But if I make it a 0, then I'll get a maximum difference, sorry, absolute difference 0. But what if I make it as 1? Then I will get a 1 as absolute difference. This will help me to maximize the maximum height. So let me make it as 1. Now I will change it to 1 here and also here. I am changing it to 1 and also here. I have made all the adjacent elements to this 0 as 1. The absolute difference is at most 1. It is at most 1. It is also at most 1. Now I have another 0 here where the adjacent cells are unvisited. Now I can also make it 0, but as I said, I will make it 1 because I can get the maximum height maximized. So let me take this. Now I am making it as 1 and also this one as also 1. Now you have only these two as unvisited cells. The values here are 0 and 0. Now I can leave it as 0. If you see, I can make it as 0, or I can make it as 1. If you see clearly, 1, or I can also make it 2, because the absolute difference between these two is 1, and between these two is also 1, and between these two is 0, and between these two is 1. So it is absolute difference max of 1. This constant is also maintained. Now, what I need to do, if I make it as 0, the maximum height in the grid is only 1. It is just 1. But if I make it 1, even then the maximum height will be 1 itself. But wait, if I make it 2 here and also make it 2 here, then I can get the maximum height as 2, which is maximized. So that is the thing why I need to make these two cells, I am making it as 2. So let me do that here. I will make these two cells as 2. Then if you see clearly, the maximum height here is 2, which is maximized, and if you see, every adjacent cell is having at most absolute difference of 1. That's all. That is how you solve this problem. Now if I go through the algorithm, which goes like, first thing which I want to do here is initialize the height matrix of size m by n and everything as -1, if you remember it. Now I'm initializing a queue so that I will be getting 0 0 and also these ones after that. So I'll be using a simple BFS algorithm to solve this problem. So this BFS algorithm will be using a queue where firstly it stores the cells where I got the water cells and I made it as 0, and then the adjacent cells which are still unvisited. That's it. This queue, initializing a queue here. Now it will be having indices I comma j, which will be stored in a pair. Now we will be traversing the is water grid, which is given to us, which is a grid, right? It is a grid, and and wherever we got water cell, that means 1, wherever we got 1, make height of ij, we will make the height of ij as 0 and push that index I comma j, the cells index I comma j into q. Now after that, while q is not empty, we'll be traversing, take the front element, that means x comma y will be q dot front. After that, we will be removing it from q, and we'll be going for adjacent cells, new x new y. It will be like the up one, the right one, the down one, and the left one. For that, we'll be using DIRS, directions matrix 2D array, which will store the directions of up, right, down, and left. Now go for adjacent cell nx ny. If they are unvisited and in the bounds, which comes in the bounds, assign them a height of assign them wait a second assign them height of nx ny. What will be the height? Because every time I got this one, I am making it 2. That means I am incrementing the height of 1. Height of nx ny will be incremented by the current cells plus 1. So height of nx ny will be height of current index, current cell x and y plus 1. That's it. That's how you solve this problem by using this algorithm. And then we'll be pushing that new x new y new x new y into the queue into queue into queue. Then after that, after making this, we'll be returning height. So if you ask me why I'm again pushing this nx ny into cube, because here you got this 0, you made it 0, and you have traversed the adjacent cells, right, these cells, and you also got -1 here. If you remember, you got this -1s here. So to get them, I am also pushing these adjacent elements every time into queue. So this is how you solve this problem. And if you want the code, stay here. So let me code this. The first thing, I'll be using int m is equal to is water dot size. M is equal to is water of 0 dot size. Then I'll be initializing, wait a second, I'll be initializing a height matrix which is of same size, vector int height of m comma vector int, and everything as -1, right, every cell as -1. Then we'll be initializing a queue which is having a pair int comma int, name it as q. We'll be traversing the is water which is given in the question for, sorry, for n j is equal to 0, j is less than n, j plus plus. After that, is water if it is water, we got 1. That means is water j is equal to 1, then height should be made as 0. Sorry. height should be made height should be made as 0. Now after that, push this index I comma j into q. That's it. After this traversal, while q is not empty, let me write it, while q is not empty, then auto x comma y, the current cell, will be q dot front. After that, we will be removing it, q dot pop for int I is equal to 0, I is less than 4, I plus plus. As I said, we will be having a directions uh, 2D array. So vector 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 int dirs is equal to 0 comma 1. Then after that, we'll be traversing through these directions. Auto dx is equal to, sorry, dirs of I 0 and dy is equal to dirs of I 1. Now new x is equal to x plus dx and new y is equal to y plus dy. Then if it is in bounds, nx is less than m and ny is less than n, and nx is greater than or equal to 0 and ny is greater than or equal to 0, Then if it is coming inbounds and it is unvisited, and x and y is equal to -1, then this height should be changed as nx and y will be changed as height of x y plus 1. Now we'll be pushing this nx and y, the new row, new column, into our queue. After that, return height. That's it. Let me run this code. Will it be running or not? Right. If you like this video, share to your friends and subscribe to my channel. I will also be uploading the LeetCode contest solutions. So thank you.